Hey everybody, welcome to the latest Cold Fusion Summit presentation. My name is Alistair Lee. I am not your normal host. I am subbing in today for Mark Takata, who is unavailable. I am extremely pleased to be here, though. It looks like we've got a fantastic presentation coming up. Today we'll be talking about modernizing through evolution, not revolution, by Guust Nieuwenhuis. Hopefully I didn't butcher that too much. Before we get started, as we move to our presentation today, you'll notice a chat pod on the right-hand side. You can use that to ask questions as we go. It's not formal. There's no moderation in that chat pod, so just play nice is my only request there. You are muted today. Don't worry about making noise. We can't hear you. We won't hear you unless you need to use the microphone, in which case you can raise your hand. But the best way to ask questions today is through that chat pod. We're using voice over IP. Hopefully you can all hear me now. We're broadcasting through your computer speakers. And as you can see from that big red button in the top left-hand corner, we are recording today's session. I'm not sure if you registered for the session. If you did, hopefully we can send you a link to that recording. If not, I'm sure we can make it available on the community. Right, enough of my yapping. I don't belong here anyway. Let's hand it over to our expert speaker today, who will take us through talking about modernizing your apps. Guust, go ahead.
Good evening, all. Give me 1 second. Yep, need to make sure that I share my screen, right window. Whoop, that goes wrong. Where's my presentation?
We're seeing your desktop, and now we're seeing your deck. Perfect.
Yeah, that's it. I was hoping to see the connect window at the same time, but I got all my presentation stuff on all windows. In a minute I'll have to switch back to see for some questions I've got. So good evening. First of all, thank you Adobe, thank you Alistair and Mark for having me. It was great to be in Las Vegas in October to meet a lot of people over at CF Summit in person after those last few years. But it's a great opportunity as well tonight to talk about a subject which is close to my heart. So that's always a nice thing. I'll start with introducing myself. I guess that's a good idea. My accent probably gives away that I'm not American. I'm Dutch. I was born in the Netherlands, and I live in Belgium, in the middle of Europe. A great country, good beer. No plans of moving away. I'm a managing partner over at We Are North. We're a small but very dedicated team of cold fusion specialists, a bit broader web specialists. A lot of the stuff we do is related to cold fusion, but not exclusively. We use a lot of Java, JavaScript as well. I'm always refer to myself as a full stack web wizard. Most important part is full stack, and web, the wizard is just a gimmick. But I've been developing since the early start of my career. Been exclusively been doing web stuff, and right from the start with cold fusion. Fairly recently, together with my colleagues over at We Are North, we took over Masa CMS. Well, actually, we took over the public version, the open source version of Mura CMS, and rebranded it to Masa CMS. That's one of the things that I've been doing for the community. And in my free time, that's always a nice thing to mention as well. My free time, during the whole pandemic and everything that happened over the last few years, I found a new passion as a soccer coach over at our local youth soccer club. I'm mountain biking, and I'm a huge IndyCar fan, which you can see on the picture on the right bottom as well. So what I'll be talking about today is modernizing through evolution, not revolution. And I've got a question. I'm quickly gonna gonna go back to see the connect room, because if you guys over in the chat could help me out for a second, I want to know what the oldest software project is that you're currently working on. How old the current software you're working on, how old that is? Is it older than 3 years, 5 years, 10 years, maybe even more? I'll give away what the answers were to the same question over at CF Summit in a minute, but I'll first leave it up to you guys to write and give me an idea of how old your projects are. So I see 13 years. Charlie, hi Charlie. Charlie, some of them are older than 10, so he's currently in the lead. I would guess, 20, Eugene? Wow. 3, 5, 10, 15, a lot of diverse answers. I'll wait for a few more answers, and meanwhile, I'll show you guys a more up-to-date version of myself by turning on my camera. 20 plus over in Sydney, Australia. Wow. Bill is what we consider lucky. He's been working on a fairly recent project. He is he's working on something which is 1 year old. Wow. So we got a few different answers here. Let me turn the slide back on. Yeah, there we go. So we've seen projects 1 year old all the way up to 20 plus years. Over in Las Vegas during the latest CF Summit, I asked the same question, and I got a few people as well over there that are working on projects that are over 20 years old. And that's actually not really big of a surprise. If you consider that the average lifetime of software is around 10 years. And if you keep that in mind, and if you start looking back a little bit, if we go back 10 years in time, we're 2023 now, just started, but if we go back 10 years in time, that was around the time in the Cold Fusion community when Fusebox had his final release just shipped. It was just out. Coldbox had just started implementing MVC. Framework 1 had released version 1.0 back in 2010. Taffy wasn't even around yet. And if we talk about some other technologies, Node was around for 3 years, maybe. It was in like really young technology. Same as a lot of the front-end frameworks that we know. Angular JS, not 2.0, but the JS version was a year old. Ember, 6 months. So what I want to point out with that is that 10 years ago, we had a complete different spectrum of tools in our hands when we were writing software. And if you consider that we started projects 10 years ago with those tools in front of us, and we've been running those projects for 10 years until today, then you could see that if we haven't invested in those, and if we continued and just maintained it as is over those 10 years, then what you get over time is projects that are struggling a bit with spaghetti code, with some outdated frameworks. We actually got outdated frameworks and supported libraries. Got a good example of that. I was involved in a project a few years ago that was still was even older than 10 years. Was using Reactor ORM, something that I've never touched in my career. And I ran into an issue, a problem with MySQL and Reactor, and the whole project was without any commit, without any development on Refactor ORM for like the last 10 years. So luckily, I managed to quickly figure out what was going on, dove in the source code, fixed it, and actually, so of course, I submitted the fix to the open source repository, which is basically the only commit that has happened in the last 10 years. But that gives you an idea of, if we're if a software project is like 10 years old, that we run into those problems. Outdated frameworks, unsupported libraries, integrations that are deprecated, which could very well mean that might be gone in a couple of months completely. So we need to prepare ourselves for that. What you see a lot of the time is that there are no tests, that they're poorly documented, if there is any documentation at all. And the result of that, what you get is that those projects are very, very difficult to maintain. They're hard to maintain, but also very difficult to develop on. We all know, I'm pretty sure most of us have been in situations where we knew that if we would touch something on the left side of the application, we would have no idea whether the right side of the application would hold up, or whether it would completely fall apart. So that's a struggle. A struggle, I think, everywhere in software development is. You could consider that over in our Cold Fusion community, we tend to have a bit more of that, because the how mature and how, I don't want to say old, that's why I say mature, Cold Fusion is as a technology, and how long it's been around. We were planning on celebrating the 25th anniversary of Cold Fusion when hell broke loose. But we're definitely not alone. It's just something we could consider happens a bit more frequently in our work. But if you consider that a lot of the technologies, alternative technologies for Cold Fusion, are as old as Cold Fusion is, that it's something we're all struggling with in all communities. So then the question is, what's next? Well, what are we going to do then? So we have this code base. We don't dare to touch it. It's difficult to maintain, hard to develop on. What's next? What are we going to do then? Well, let me tell you a story. We're going to go a few years back in time, when I was working at a company here in Belgium. They hired me as a freelancer to help out on developing their flights booking engine. What they basically developed is a platform running on Cold Fusion, which they use to build websites for clients of theirs, so that those clients could sell flights. You would go on the website, you would type in, okay, I want to go from Brussels, Belgium, to Las Vegas for CF Summit. You put in the dates and you say, well, let me know what flights I can take. And you get a whole nice view of a lot of your options. And they built that. They had this engine. They built multiple front ends against it for different clients, and that was running all fine. But they were running into performance issues. And to be completely honest, I wasn't involved in those decisions, but they tend to resolve performance issues by just adding additional servers. That was the years before I arrived. That was basically the way they would operate. Okay, everything is the load is too high on the system. Let's just put it on a few more servers, and it'll keep running. But until a certain point, you can continue doing that, but that doesn't hold on forever. And the story goes, and I'm clearly saying the story goes, I wasn't there, but the story goes that the CEO, CTO, they were in the car driving back from a client's meeting. Client was unhappy about the performance of the system, but not only that, also the speed in which they could deliver new functionality. If something is old spaghetti and all old code, and it's hard to develop on, it takes a while to implement new functionality. So that took a while, and they decided they were kind of started blaming Cold Fusion for that, and decided that they were going to rewrite the whole system from scratch. Story goes, they were in the car, and one of the two mentioned to the other, okay, what technology should we pick then? Oh wait, we've got somebody around in the team that used to do some .NET in the past. Okay, let's try out .NET then. And they started rewriting the whole engine in .NET. But what they did while they were doing that, they kept developing the Cold Fusion version as well. So I was brought on board in the team for the Cold Fusion version, and we kept adding new stuff, new functionality, kept developing on the old engine, to say so, while they were developing with the new team the new engine. But the new team was basically trying to catch up. They were already behind because they had to start from nothing, but we were adding and adding and adding and adding. And we all know how Cold Fusion is a rapid application development platform, and that went fast compared to other technologies, for example. And so they were constantly trying to catch up. And I think it took them years. I wasn't even around anymore when they finally managed to catch up and release the new engine. But they had put so much money in that. That it became a financial disaster. They had to file for Chapter 11, and it was shortly after. I think they sold the new platform to continue on one of their other products, but banks and investors pulled the plug, and it was over. That brings me to an interesting quote from Joel Spolsky, who's the co-founder of Trello and Stack Overflow that we all love and visit regularly, if not so every day. Rewrite code from scratch is the single worst strategic mistake that any software company can make, he claims. And it's not something that he claimed recently. That's something coming out of an article on his website, joelonsoftware.com, back in 2000 already. And he basically describes how we programmers, that in our hearts were architects, and that whenever we arrive at a site, that the first thing that we want to do is take the bulldozer, flood the place, and just build something beautiful, new, shiny thing. That we're not really excited by incremental renovation, all the tinkering, the improving. We don't. That's not our thing. We want to build something great and new, and that's because there is a very simple reason why we always tend to throw away code and start over, and that is a really simple thing, being that it is hard to read code. It's harder to read code than to write code. That's why every time we inherit a project, or we inherit some code from a colleague or a new client, that we have a hard time going through that code, understanding what that code is. And it's a natural reaction from us to think, but if I write it, it's going to be so much easier. That's the main reason why we always end up in that idea that tear it down, we're going to start all over. We'll do it better. But the reality is that a feeling isn't sufficient. There are 5 reasons why you shouldn't. And the first of all, like I said, a feeling isn't sufficient. The idea that if we start all over, it's all going to be better. It's purely emotional, and we shouldn't make that decision purely on emotions. On top of that, rewriting basically delays the release of the project. When I go back to the story I just told about the company here in Belgium, the good thing they did is that they didn't stop development on their existing engine. You see companies do that sometimes. They want to rewrite and they decide to stop all effort on the current system and shift focus completely to the new system. But that means that for a period of time, you're not going to deliver any functionality to your existing system, and the rewrite is going to delay the release of the whole project. So you get this time frame in which you're not delivering any business value. On top of that, rewriting is going to result into more bugs and potentially less functionality. Not to say that it's a really expensive undertaking to do so, and that there is no guarantee at all to success. When talking to other people, especially in Vegas, after I gave this presentation over at CF Summit, multiple people confirmed it and came to me with stories of their own, where they went through these scenarios, and well, I'm not going to say none of them succeed, but it's rare that a complete rewrite of a system is a success. There is no guarantee that's going to be a success. So let's go back then. What's next? So I hope I made my point clear that we're not going to rewrite. That we're not going to rewrite our system, but we do need to get to a solution. We need to find a solution on making sure that we get those potentially get rid of the unsupported frameworks, the unsupported libraries, that we have a solution for the dependencies that are deprecated, and so on and so on and so on. Let me tell another story. This is the theme of today. This is about a project I've been involved in, and we're involved in with We Are North, which is a Cold Fusion web application over 12 years old that we inherited. They came to us and they said, "Could you guys take care of it?" We said, "Yes, we would love to, no problem." Old frameworks, old libraries, the payment gateway is deprecated, and so on and so on and so on. But the first question they had when they came to us after, "Could you take care of it?" was, we want a mobile application to deliver part of the functionality as well on a smartphone, so that the users could use their smartphone and do that kind of stuff, do certain part of their work on their smartphone. And we thought, and we said, okay, so we have this very old library, API support, none. So do we want to integrate, and do we want to build an API on top of that? Is that a good idea? How are we going to approach this? And we really quickly made a decision to say, okay, we're going to create an API for the mobile app, but we're going to make that API a separate code base from the existing application, so that we don't continue on that old code, but that we start something new. And that's why we created a separate API for the mobile application. And that was the first step. Once we had that and the mobile application was out, they came back and they said, okay, we have some serious changes we want to make in the flow of creating a report. And we looked at it and we thought, well, actually two things. They wanted to add functionality, but also fix the fact that there is drag and drop functionality in there, which was developed before touch came out. So it doesn't even support touch. The report builder, the old report builder, works fine on a mobile phone until the step where you need to drag and drop because touch is not supported. And we looked at it and we said we could fix those things, but when fixing a bug is one thing, but adding new functionality is another. So we looked at it and we said, okay, we'll need to touch the data model, we need to touch the interface. Why don't we rebuild part of the application, and do that in a proper way, a modern way? We want for a new approach for the application. And that's what we did. We integrated a new module into the system. I've got a little sketch here on how that looks. We already had that mobile API for the mobile phones, and as part of that new code base, we also developed a RESTful API we could use together with a new client-side application, a single-page application with using a modern JavaScript framework. And we would have that code base all talk just to the same database. That's what we designed, and we started doing that. And on top of that, we also started working with feature flags. Feature flag, why? Because those feature flags allowed us to enable that new functionality that we had to first our client, so that they could log in and start using that, and then little by little make that available first to some core power users of the system. They could give some feedback on it. We could iterate it, improve it until we release it to everybody. And I've got a screenshot on the right side on how that looks. In a earlier stage, you could see that because the menu on the left side first has the old menu, and below it report builder v2. You see that we started building a new menu as well with that new functionality. And what we did here is that we used we load on the page, we load the single page application. So everything you see on the right side is a single page application which is loaded inside of the old application. We did a little bit of magic, not too complicated, with authentication to make sure that that's covered, so that people didn't need to log in twice. And we basically load the whole application, the whole single page application inside the frame of the old application. There's some small tips and tricks. We made sure that whenever somebody logs into the old application, there we added a tiny little bit of code to make an API call to the new API to also get back a token. Yeah, a token, so that and we would save that token in the ColdFusion session, and by the time they would end up on one of the pages where we have single page application, we would pass that token onto the single page application, and the single page application would start communicating with the RESTful API for its data. And the other thing we did is that in single page application, we have a router implemented, but we don't have a menu. What we basically do is that based on the different views of that single page application, they are linked to the different menu items on the left side menu you see. So that's what we did with this project. That's one approach to, okay, how are we going to do? How are we going to modernize our application? I've got a second story. This is regarding another client of ours. The company I worked for a few years, and they I felt immediately after joining them, I felt really close to them for a simple reason. They have a 25 plus years old client server application, and that application is developed in Smalltalk. And if I may say so, and this is with a big smile on my face, I'm joking a little bit. I felt connected with them because I think you could, if you could consider ColdFusion being the language that has been declared most dead over the years by the rest of the world, Smalltalk is its brother or sister in the client server ecosystem. They've been the amount of times Smalltalk has been declared obsolete by people that are unknown of what the power of it is. You probably can't count that anymore either. That's all joking aside. They have a tremendous great application. They're a company with clients worldwide in both the public and the private broadcaster sector. So basically, Nickelodeon is one of their clients, as well as MTV, BBC over in the UK. Every public or private broadcaster in Belgium and the Netherlands is using their system. Why? Because they use the system to schedule whatever you see on both linear TV as well as on demand, which is video on demand, which has become rather popular in the last few years. So they have this application client server, but they realize, they see what's happening around them in the world and in IT, and they realize, okay, we need to do something with the cloud. And they started investigating, and that's why shortly after I came on board, in a very early stage, doing a lot of research and development on, okay, what are we going to do? Are we basically going to expose an API from that Smalltalk application and then basically write a single page application to communicate, to have an interface that communicates with that API? Or what shall we do? And they quickly came to the conclusion, okay, let's start and dive in this whole cloud thing by developing a new module for their product, so that they could make a clear use case for what we would be doing and see how we are going to do that. We worked a lot with domain-driven design to scope what we would be working on, and we decided to go forward with a microservice architecture. The idea of writing against and communicating with an API in the Smalltalk layer was abandoned after looking into that, and we decided to go with a microservice architecture. I got a little drawing out of that. Where we would write a brand new single page application talking to a brand new backend, and that backend would have its own proper database, where all these the silos you have in a microservice architecture. That's what we were aiming for. And then, okay, that's great, but how do you then communicate and make sure that have data going left and right? Because we were writing a module around the concept of rights management, but we needed information from the database on the different movies and TV series and everything. And that information is in the legacy system. So, okay, how do we get that out? And so what we did is we created a dedicated database for the new microservice, but we had a lot of events between the microservice and the legacy system, to call it that, back and forth to make sure that we were aware of what we needed. A bit of code was added to the old backend to have a couple of hooks where we would if certain data would change, that an event would be announced, that we would pick that up in the new microservice. We would update our database, and the other way around. If something would change in the new microservice backend, that we would push an event, and that would be picked up by the legacy system, and that the legacy system would update its data as well. That's the approach we went to. How do we do this? I talked about these two stories on what we did, but there is a common approach in how we dealt with this and what we did. And that's, first of all, we needed a case, more precisely a business case. Going back to the first example, the question came to build a mobile app. We needed an API specifically for the mobile app. So that's the case. The case wouldn't be purely technical, where we would say we want to rewrite everything because it doesn't look good. No, that could have been a reason, but no, we had a business case. We had some functionality we needed, so that the project and the product could move forward, delivering new functionality to the users. Same counts for the second case the second story I talked about, where we would develop a new module. That's a new case, a business case to do something. Secondly, very important, the next thing to do is set a clear boundary of what you're going to do. If I go back one slide, we see a picture here of an airport shuttle. I'm going to refer back to Vegas. When I arrived, I needed transportation from the airport to the hotel, and for that you can use an airport shuttle. But let's imagine that the hotel has no functionality for that in their IT system, and they want to add something, so they could move forward and say, okay, we're gonna add something to step away from Excel for managing our shuttles and have an actual system for bookings and to organize our shuttle service. What you see here on the image is that what you would do then is set a clear boundary of what you're going to develop. And it could very well be that there is an overlap with what you already have, because you will already have your customer and the customer data available in the hotel booking engine. But for this shuttle booking engine, there are certain things that are very specific to that, and you want to set a clear boundary of what you're going to do, and data-wise, specifically, functionality-wise, data-wise, what will we need? But if you don't set that boundary, you potentially end up rewriting the whole booking engine as well, which is not the goal. So that's why that boundary is so important. And then a strategy. And that's the most important thing. How are you going to approach this? And I talked about the two cases before and the strategy we applied there. And I think in both cases we could talk and we could clearly define that the strategy over time would be the strategy of the strangler fig pattern. Strangler fig pattern is refers to the strangler fig, which is a plant or a tree that basically has this habit that it would overgrow another tree. And that's what we want to do with the system as well. If you want to modernize your application, your code base, you want to start small, right? Create some functionality, a new module, and little by little doing one after the other of those refactors and improvements into your system. You'll take over the old code base and start replacing it until the point where you can take the old code out and just continue with a brand new modern application that you've rewritten, not from scratch, but over time using that pattern. And that strategy, to come back to those strategies. So the first one I describe is a strategy where you have a clear bubble context. You develop a new model within the legacy application where you say, okay, for this one, we're gonna do things differently. We're gonna start using CFCs. If it's a very old system, never used CFCs. Okay, now we're gonna start using CFCs. We're gonna start models, controllers, views, write the code really clearly, nicely in a modern fashion on how to do that. That's one strategy you could go for. And then the other strategy that I also talked about already is that you could write a new application next to the existing application that includes the new functionality but continues to work on the same database. You could very well integrate that very nicely. There are different approaches, and what we did where we basically loaded the new application inside the old one. It could be the other way around. You could start like that, loading the new one in the old one, and over time load the old one in the new one, and then make the switch, the transition that way. Or you could have them side by side on a different folder on the server, but try to share authentication if possible, and user management, because that'll definitely make things easier. But this is all by using the same database. I think those first two don't seem very difficult because you continue over the same database. It's when you want to completely change your data model that it gets a little bit more complicated. But there's a pattern for that. There is a solution for that, a design pattern called the anti-corruption layer, ACL. It's a layer all about mapping one domain onto another, so that the new domain that you design doesn't doesn't need to be corrupted by the old one and the decisions that have been made in the past. And what you do in this case, for example, is what you see here. Your new application would connect, would communicate with that anti-corruption layer in your legacy application. And that anti-corruption layer would then translate your data model from your new application into the data model of your old application, and then serves it to the database. Saves it to the database in the old model, but it makes sure that your new application has that new modern approach to its data model. And here as well, over time, you could transition into a situation where it becomes the other way around. For example, that the old application communicates with the new application, and the anti-corruption layer is to convert the old model into the new model so that it can be saved in the database. What you could also do is synchronization with that anti-corruption layer. And this looks a bit like what we did in the second case, where we had that microservice architecture. This looks a little bit more like that already, where based on database actions, you would basically you would save you would have a dedicated database for the new application. But anytime you would do something in there, you would save something in there. You would also send it over to the anti-corruption layer so that it would be transformed into the old data model and saved into the database. This can be as simple as a nightly batch script that does that. It doesn't need to be real-time complicated. If you would just have something that synchronizes this overnight, for example, depending on your use case and whether that's a possibility, it could be as simple as that. So you don't need to make this too complicated either. If you go one step further, you could work with an event queue, and that's where you would basically announce between the two applications what's happening on your with your data, so that you could keep your data in sync between the two applications. And just to make that clear, and to make it easier as well for future cases, if you work with a microservice architecture, one of the advantages there is that every microservice you create, every pillar, every silo, to say it like that, every silo, the database does only basically needs to have the information it requires for its microservice. And what I want to say with that is that if you have a system that deals with flights and with flight bookings and hotel bookings, and you have a microservice for the flights, that you have all the flight data in that database, but for the hotel microservice, for example, needs specific information about hotels. Well, that information is not necessary in the flights microservice. So there, at that point, what you would not put that in that database over there. You would synchronize between the different microservices the data which is necessary to be shared between them. But so I gave you an idea, an approach how to do this. So make sure that you have a case, that you set your boundary, and that you have a strategy to go forward. You could start really small. You could start with that first strategy, and then over time start implementing the more complex strategies. There's no need to immediately dive tomorrow morning, start redesigning the whole system with microservices. No, you could easily look tomorrow morning onto the backlog or the sprint log of what's waiting for you, and pick something and say, okay, I'm gonna write this differently than the way we used to do it. That's the first step already. That's already an evolution towards a modern application. But keep in mind, if you keep the same habits, then you're gonna keep making the same mistakes. So make sure that whenever that you make sure that you start changing habits today, if not tomorrow, to make sure that you're prepared to writing a more modern code base for your application. I've seen it multiple times that people have great ideas on how they're gonna write, how their approach is gonna be if they start all over. And where I'm wondering, but why don't you already why don't you already apply those techniques like with your next ticket that you're gonna start working on and you're gonna start fixing? So keep that in mind. If you keep your habits, you're gonna keep your mistakes. So that's something you need to break. So if you want to read more on this, there are a few. I would say to quickly take a picture of look back at the slides afterwards or the video recording. But these are some keywords on the screen here. I mentioned domain-driven design earlier on, feature flags as well, microservices. These are, if you want to know more on this topic, you should definitely Google these topics that you see here. Let me quickly explain a few. Eric Evans is the guy, is one of the guys that wrote a few books and wrote a lot on domain-driven design. So if you look for his website, you'll find a lot of information there. Martin Fowler is the guy who actually was one of the first to describe the strangler fake pattern. An event-driven architecture. I mentioned anti-corruption layer. We don't need to look too far. We could look in our own community as well, because if I mention feature flags, some people it'll probably ring a bell that Ben Nadell has been writing and playing with this concept a lot recently. So definitely go check out his blog if you want to know a bit more about feature flags, and Google all these to dive into a very interesting topic, I would say. But I have one more thing. I have one more story actually, and that is a project that I'm currently working on, that I've been working on this morning, that I'll be working on tomorrow. It's a project where we're actually gonna rewrite the system. But let me explain, because I've been, for like 45 minutes, I've been explaining you how to not rewrite your whole application, and I've been giving you alternatives on how to do this. But let me explain why we are going to rewrite this system. There's a very good reason for that. First of all, the company has three applications that have overlapping functionality. There are no copies of each other. They have overlapping functionality, but all three of them are written in different technologies. The main one is maintained and developed in-house. The second one is like half. It's like on a low-code platform where a lot of external consultancy is necessary because of the complexity. And the third one is basically it's maintained and developed. It's completely outsourced. The reason why we're gonna redevelop is because we eventually want to end up with a single system, and there the approach is that we would gradually move the different systems into each other and eventually end up with a new application. And we're going to start with writing a minimum valuable product, and if that minimum valuable product will very quickly match the functionality of the smallest one of the three applications, and that would be the point where we would basically move over all those users onto the new platform. But another thing is that we're potentially not going to copy all functionality over. We're going to use this opportunity as well to cut away parts of the applications that are not used a lot. The reason why we are going to rewrite this, and that's a very, very important big, small detail, whatever you want to call it, but it's a business case that drives rewriting these applications and rewrite these into a single application. It's not because of technical reasons. Yes, all the developers are pretty happy that we foresee to step away from the old code base, probably in a few years. But it's a business decision, a business-driven decision to rewrite, not a technical decision, not based out of emotion that would be so much easier if we're going to rewrite. That's not what drives this. What drives this is the business case, and that's what makes this different, and that's what makes this a case where I would say, yes, rewrite. So yeah, that's the story I wanted to tell, and that's why what I wanted to talk to you about, how to modernize, and don't do that with a revolution. Don't start all over, but do that with an evolution. Start modernizing your application tomorrow with a simple small thing in one of the tickets or one of the new functionalities you're developing, and the month after with a small design on how you're going to do that, and potentially in a couple of months by changing your architecture and creating a new module, for example, that is completely rewritten in a modern approach. And little by little, through evolution, take over your old code and get it obsolete and get all the new code in place for your system. Questions? Let me give me a second. I need to make sure that I move away and figure out where the connect window is. There we are. I'll stop sharing my screen so that I can see you guys, your questions in the chat. I don't know whether you guys have questions. I'm open to all of them, so please let me know.
Lots of great chat, lots of great comments. Not too many questions, I don't think, for you. But now is an ideal time. If you've got any questions, stick them in the chat.
I'm definitely going to take some time after we're done to go through the chat and see what you guys. I don't know whether anyone shared stories of their own. It doesn't need to be a question. If you have a story to share similar to one of the stories I talked about, go ahead and share them with us so that yeah. Okay, so Bill, I think I understand from your last comment that you relied on MVC. It is indeed a whole other talk to get into, but let me think if we can direct you to some resources on that. I would maybe the easiest would be to look at a framework like Framework One, which has MVC as one of its core concepts, and is light and small enough to get an understanding of what it is. Coldbox has a great MVC as well, but because of the fact that Coldbox is such a richer and bigger framework than Framework One is, potentially Framework One is an easier one to get started to get yourself familiar with the concept of MVC. And yeah, and that event communication is really interesting. It not only while modernizing your code, but even if you have multiple systems that need to share information with each other, that's the really interesting approach to things. And you could go as complicated as message buses. Kafka is one of them. You have there are multiple solutions out there to set up streams of data between stuff. But if you sometimes you could keep it simple as well, and just make sure that you have a few hooks in your application, and whenever something happens. Whenever, for example, a new file is created, that you would, for example, just call an API endpoint from your other system, and make sure that you pass the information on and do it like that. The moment you get multiple systems involved, of course, then it becomes interesting to work more with like a more complex system like a message bus, because then you can basically put it on there once, and all the other systems will listen to whatever happens on that message bus and pick that information up. Yeah, yeah, all HTML, sorry, all HTTP between the containers. So a question: these triangular fake patterns are same stuff like the models created for the AI. With AI, I guess you mean artificial intelligence. Um, when we said that MVC is a complete different topic, I would say that AI is a complete separate conference. I'm not familiar enough with AI, and it hasn't triggered my interest that much that I can give you a good answer on that question. I'm sorry. So Misha, you asked. So what I meant with old code. Every code do something. Every code do some specific task, and if it does, how can it be old? Um, well, when I'm talking about old, um, I'm talking about the age of the code, and more specifically, um, if it could very well be that that 10-year-old code is still very modern. Um, but so it's so you wouldn't I wouldn't say that we would define old as the how many years ago it's been written. That overall that kind of works but I would say old in a sense that it doesn't um, uh, match the modern approaches and the new habits we've taken on writing software over the last few years, I would say. Nice to hear, John, that you have a similar approach to modernizing your applications. Because if I'm not mistaken, it was you who mentioned all the way at the start that you're working on a system which is more than 20 years old. So um, that's great to hear. And yes, if as part of that modernization, moving from on-premise to a cloud-first approach is another big challenge, and probably another whole different topic, another hour to dive into. Yes, of course.
Fantastic. We have hit the top of the hour, so I'm going to wrap things up. Who's Thank you so much for today's session. Fantastic content, fantastic
You're welcome. Thank
delivery.
you.
And thanks everybody for joining. These CF Summit sessions are fantastic. Thank you all. We'll see you at the next one coming up shortly. Until then, have a great day. Bye bye.